So let's say that we have two objects that they both fall, but the one of them starts a second later. So what is happening? So the first one starts falling, meaning its velocity changes in the way we said, and its position changes in the way we said. Now the second one starts a second later. So it starts moving now, so its velocity will be negative 9.8 here, it will be negative 19.6 here, it will be negative 29.4, and of course the same thing will happen with its position. So after a second it will be 4.9, and then it will be negative 19.6, and then it will be negative 44.1. You will see that the values we have are exactly the same. They just happen a second later, right? Now, what does that mean? What is the distance between these two objects? All right, let's talk about the distance between these two objects. So here the distance is 4.9. What about here? How much is it? Well, it's 19.6 minus 4.9, which gives, oops, I didn't do it correctly. It's 19.6 minus 4.9 equals 14.7. What about here? What's the difference between these two positions? 44.1 minus 19.6, it's 24.5. So what do we see about their positions? Do they stay the same? They speed up in the same way. Their velocity change in the same way. Their position changes in the same way for each one of them separately, but their distance, their in-between distance increases. That is why, for example, when you have athletes running, the person who starts first usually manages to create a difference in its position from the others. So it is important for the athletes to start first. That is why they have all that stuff, because they have to start as fast as possible, because from that point on their distance from the others will be increasing. All right, it has to do with this. It's the same idea, no matter if the motions are horizontal or vertical, the idea is the same.